Okay, let's check out this new decentralized asset from Dynamo Defi. So this is a way of managing algorithmic USD stable tokens, and it'd be DAI and Frax, GHO, and having them, giving them optimal investments into various lending platforms, so that you don't have to worry about where you're going to be getting the best interest rate. And it does this by crowdsourcing a strategy to say, okay, we've got these various lending platforms that the vault is attached to, and what is the ratio that we should distribute the funds across those lending platforms. So this is our documentation for the system. We've got this visual here. The system is initially designed to work within the balancer ecosystem in what they call a boosted pool. Now, boosted pool and balancer is really a composable stable pool that includes a linear pool for each of the algorithmic stable tokens that we're going to be supporting. So in this case we have DAI and Frax, but you can have as many of them as you want. And these are, so the composable stable pool is a balancer pool, the linear pool is a balancer contract. Those are both in Solidity. We've got another video where we talk about the balancer integration. That's not what we're talking about here. Here we're just going to talk about the Dynamo 4626 vault that we created. And this is all done in Viper. So it's all the blue bits here and the adapters that connect to the various LPs. So in this case, we have one contract, which is the Dynamo 4626 vault, and it is actually composed of a few other contracts that can be upgraded into it. Now these are stateless contracts that actually can't move funds or do anything, so they're very secure. So we have a funds allocator, and then for each LP that we attach to, we have an LP adapter contract instance that connects to it. So each Dynamo 4626 vault can have different LPs than the other one, because, for example, not all algorithmic stable tokens are supported across each of the LPs. Also, in this case, we have the same funds allocator contract, but you could actually allocate funds independently for each Dynamo 4626 vault, and also each one gets its own strategy, obviously because it could have different LPs. So that's the structure for that. In our formal documentation, we have formal descriptions of all parts of it, and we have use cases defined in sequence diagrams for all the core use cases of the contract if you want to go on and do a more formal investigation of the code. But we're not going to do that today. So here is the 4626 contract. A couple of things that are fixed at compile time and cannot be changed once the contract is deployed. The maximum number of pools. This is the number of LP tokens or LP contracts that it can manage. So this is 5 right now, and also the fee percentage that the contract owners take is fixed, and in this case is at 10%. And whoever is the strategy proposer gets 1% of whatever fees are earned while their strategy is in place. So this contract, it's about 1,100 lines of well-documented Viper code, and supports the 4626 protocol completely. We were talking about the upgradable aspects of it. So for each LP, there is an instance of this virtual interface, which is the LP adapter, which supports max withdrawal, things that 4626 needs to support moving funds in and out of it. So 1, 2, 3, 4, 5 APIs is all that's necessary. And so this is mapping to these non-4626 LPs, like in this case Aave and Fraxland. So Aave is more complicated on the things you have to do to integrate to it, and so this is their contract. It's not that complicated, but it's not an exact one-to-one relationship, so it's a little bit more code. Fraxland, on the other hand, is really close already to what the model of the 4626 is, and so its code is much simpler. It's not very difficult to add a new LP to the system. The funds allocator, we separated that out because this is where the logic goes whenever you're rebalancing the vault, and that can be done through a direct explicit call to rebalance the vault, or anytime you move funds in or out of the vault automatically generates a set of transactions that is the optimal way of moving funds to achieve the ratio balance that's established by the strategy. So anytime you move funds in and out, the system gets rebalanced. The logic for that rebalancing is here in the get balance transactions function. You'll notice this is a view function. It's actually a pure function, but you can't make external functions pure. So there's no state at all that it has. Everything is passed into it, and we have this get target balances, which actually defines what the optimum transactions are. Another thing that it has is this is also where we inject an additional safety measure. So really the only exposure that we have where people could lose funds in one of our Dynamo 4626s is if the lending provider itself were exploited somehow. And so we would detect that, because the next time we would look at the value that's in that LP based off of the assets that we have, if it's lower than the value that we saw before, then we can assume that system has been exploited. And we check that out here. We just check if the current pool balance is less than the last pool balance that we saw. We will then, instead of allowing more funds to go into that adapter, we will block it from receiving any more funds, and we'll show you how that works in our demo. So let's actually go look and see this thing run. So our actual what we're doing is actually running a functional acceptance test, but it's using the unit test model that we used during our development, and that is running against a snapshot fork of the Ethereum mainnet. So that means all the contracts that we're talking to, Aave, Fraxland, Compound, are the actual contracts as deployed on Ethereum mainnet. And so everything we're interacting with is if we were doing it on mainnet with the actual code that's there. There's nothing simulated about it. It's just that we are taking snapshots from a certain block, and then we're moving forward from there with the actions that we're taking. So let's kick this thing off. Chain ID 1, Ethereum mainnet. Deploying a bunch of things. We're going to make some initial deposits. So in this case, here's what we've got going on here. So we've got a trader wallet. This is the person who's going to be interacting with the vault. They have 10 billion DAI, but they elected to deposit 100,000 DAI into the contract from the beginning. So they now have 100,000 DAI, which is the Dynamo DAI, because this vault is for DAI. And so that's the balance here. And the 4626 contract has 100,000 ADAI. So this is actually DAI that came from Aave. This is the wrap DAI from Aave. And here we are. The 4626 presently has a total supply of 100,000 DAI. It's also its total assets and total deposits. And there's been no returns because it's a brand new contract. Now, we only have Aave as an adapter on the contract right now. So what we're going to do next is we're going to add the compound adapter to the 4626 contract, and we're going to give it a 1-to-1 or a 50-50 ratio between the two. So we'll see how that looks here. So this right here is, so since there is in our contract there's a maximum of up to 5 adapters, so we pass the strategy for all 5. There's only 2 of them present, so here's the Aave contract address. It's got a 1 ratio. Here's the compound contract address. It's got a 1 ratio. So 50-50 is what we're proposing here. Now, anytime a new strategy gets set, it doesn't actually move any funds yet. What moves funds is by calling an explicit rebalance function or moving funds in and out of the system. So actually updating what this new strategy should be is a very cheap call. So now we're going to just manually rebalance the system. And so presently we have 100,000 in assets for ADI in the 4626, and what we should see is we should see 50,000 of that move down to CDI, which means it's been deposited into compound. So let's execute that, and that is exactly what's happened, right? 50,000 deducted of ADI, and that's been then deposited into compound, and so now we have 50,000 worth of assets in CDI. So now the trader is going to deposit another 10,000 DAI. And boom, and as you expect, it got split into two, 5,000 into Aave and 5,000 into compound. And so all of our balances look correct. Now we're going to try to generate some interest. So we're just going to move forward 350 days. It's going to be a small amount of money because obviously we're not causing any transactions to occur on the Aave contracts or the compound contracts. So this is just natural interest that would appear. So boom, 350 days later, the interest is $1,152.95 DAI, and compound gave us 29.53. So compound not generating as much interest as Aave in this case. And so our assets have increased. Our total returns in the contract are now 1182.49. And here we've got some fees. We've got 10% of that value was allocated towards the claimable yield fees that are available, and 1% towards whoever hold the strategy while that occurred. These funds will remain in the contract until a request has been made to actually remove and collect the fees. So fees compound along with the other assets. So as long as the fees hold in there, then they belong to the assets. So now the trader is going to remove 50,000 DAI, going to take a withdrawal. And as you can see here, there's a little bit more ADI than CDI because Aave earned more money. So this transaction is going to result in a balanced 50-50 split between the two after it's done. So it's going to remove more money from the Aave than it is compound in this case. So let's see that transaction happen. And there it is. Yeah, this little over $25,000 out of Aave, a little under 24. It only required 49,526.16 of our DAI shares in order to get 50,000 worth of DAI because of the compounding interest, the additional returns that we received. So our trader has made a little bit of a profit. And so you can see the supply has been moved. And but it's like, all right, well, Aave is obviously performing right now much better than compound, so we believe that we should adjust our strategy. So we're going to throw 75% of our allocation into Aave and 25% into compound. So let's activate a new strategy, and here it is. Here's the Aave contract address, and it's now got a 3 ratio rather than a 1 ratio compared to compounds. It's 1 ratio, so 3 to 1, it's going to be a 75% allocation. And again, we haven't rebalanced yet, but what's going to happen next is the trader is going to deposit 5,000 more DAI, and this will result in a complete moving of all the assets. So at the end, we'll add the 5,000 new DAI, and there'll be money moved from compound into Aave to balance out to a 75% ratio. Let's kick that off. And here we are. So Aave has, so compound, we took 14,000 out, and we moved the 5,000 plus the 14,000 into Aave, so that's 19,000. And so now we're at a 3 to 1 ratio. We got 75% into ADI, and the trader now has additional DAI for his investment. So let's kick off and do some more yield, another 350 days. And yep, okay. So we've earned more money here from DAI this time, and so we've got some more fees here. Now, so things are going good, but let's pretend that somehow, some way, Aave was exploited, and funds were removed from Aave, which would mean that the next time we look at our balance on Aave, it's going to be a smaller number than what we saw the last time we put funds into Aave. So first of all, we're going to simulate the loss. So we simulated that $20,000 dollars is missing from the Aave contract, and so now our balance is only 30,000 in of ADI, and our assets have gone down, our returns have gone way down. Now we're at negative 17,000, and all of our fees have been wiped out because of this exploit. So that sucks. But we haven't actually moved any funds. The 4626 contract is not aware that this exploit has happened yet because nothing has occurred. So what we're going to have is we're going to have the trader is now going to deposit 5,000 DAI into our contract, not knowing that Aave has been exploited. Now, a naive contract would try to rebalance these assets, this 30,000 to 16,000 plus the 5,000 you're going to deposit, and would try to move those 75% of that into ADI, which basically means since it was exploited, it's actually going to get more funds. It's going to drain funds from the other LPs, and it's definitely something that we don't want to happen. So then our security protocol should kick in, hopefully, and prevent that from happening. So sure enough, we did move funds out of Compound that were intended to go into Aave. But when we were looking to build the transaction to move the funds into Aave, we noticed that its balance was lower than what we expected. So instead, it just held those as DAI into the 4626 vault for now. So that kept us from moving additional funds into Aave, and so we're not subjecting these new $5,000 in additional funds to this exploit. So now the trader is going to put in another 5,000 now that we've already seen this. So what's happened is now that the Aave adapter, even though before the strategy was 3-to-1, excuse me, the new value is going to be 0-to-1 for Aave to Compound. And so the next transaction will cause everything to rebalance so that all of the funds should be moved into Compound. And so that's exactly what's happened. We've now taken the balance of the DAI that we had in the 4626, all the balance that was in Aave, plus the 5,000 that came in from the trader, and moved 100% of our funds into Compound. And so that will stay that way. No funds will move into Aave until a new strategy is confirmed that allows Aave to receive funds again. So until they evaluate why this exploit happened, why those funds went down, some explanation. Otherwise, it's out. We can also remove the Aave LP from the adapters completely if the contract owner wants to do that. So that's the core functionality of our Dynamo 4626.